Hi guys, if you are viewing my channel first time, please subscribe to my channel for more updates on machine learning. Today we are mainly discussing about an extreme gradient boosting or XGBoost. It is one of the supervised learning technique in our machine learning. By using supervised learning technique, the prediction can be made. Mainly XGBoost follows the boosting technique in case of model training and also prediction. That's why we'll discuss more on ensemble techniques here. Ensemble techniques are two types, bagging or bootstrapping aggregation, and second one is the boosting. Bagging or bootstrapping aggregation is a parallel process. Boosting is a sequential process. Okay, we will discuss more on bagging and bootstrapping aggregation here. We will take example 1000 data records in one of the data set. This random 700 records we have taken for the original training data. This original training data we are dividing into the multiple data sets. Data set 1 random 400 records we have taken from this original training data, that we are mentioning it as data set 1. Similar way, data set 2 random 420 records we have taken from this 700 records, that we are mentioning it as data set 2. Similar way, data set t minus 1, data set t. Okay, here once we have the data sets, then we can build our model. For example, this data set, the target data categorical or binary, then we need to apply the classification model. For example, if my target data is continuous data, then we need to apply the regressor model. Similar way, if my data set target data is continuous, then we need to apply the regression. In case of my target data categorical or binary, then we need to apply the classification. Similar way, we need to apply classification or regression. We need to build our model, classifier or regressor. Then finally, we need to combine all the results to get our prediction. For example, in case of classification, okay, we need to take the highest voting. In case of regression, we need to aggregate all the results. Okay, we will take one example. For example, we have four classifiers. The classifier 1 output is true, classifier 2 output also true, classifier 3 output also true, classifier 4 output also false, for example. Okay, we have highest voting with respect to true, we have very high. That's why we'll take true is my prediction. Okay, similarly, in case of regression, the regressor 1 output is 10, regressor 2 output is 20, regressor 3 output is 30, regressor 4 output is 40. Then we need to add all the regression results, then divide by 4. Then that aggregation results we are taking for the prediction. Okay, these are mainly random forest follows this banger bootstrapping aggregation in case of model training and also prediction. Okay, here today we'll mainly discuss about on the boosting. Okay, in case of first iteration, we are passing the 10 records, 5 blue records and 5 red records. Okay, but it was classified only 3 records as it is, but 2 records are classified as red. These two are misclassified in the first iteration. Okay, that's why I'm going for the next iteration. Two misclassified in the first iteration, that I want to classify exactly in the next iteration. That's why I'm going further. I'm drawing a line here. These two records are classified exactly, but three other records are classified as red. These three are misclassified in the second iteration. That's why I'm going further iteration. I'm drawing a line here. That 5 blue records I classified exactly, but other red records are classified as blue. Okay, these 4 are misclassified in the third iteration. For example, if I calculate the efficiency, let us assume we have 30% I got from the model 1. For example, next 30% I got from the model 2. Next 30% I got the model from 3. If I combine all the models, then I will get the better efficiency. Okay, here just all the weak learners I am combining, I am just getting the strong learner. This is the way the mainly boosting technique will work. Mainly ADA boost, gradient descent boosting, and also extreme gradient boosting always follows this boosting technique. Okay, we will discuss more on XGBoost today. We will take one classification example and how we will train and also how we will predict. XGBoost can be used for both classification and regression problems. It will solve both the problems. Okay, here we'll see how the model is training. Okay, here I am just passing the x and y. We have the independent data x1 and x2 I am passing to here, and y. Okay, x and y, what is my target data, what is my independent feature I am passing to the first decision tree. I am just building my decision tree and I will get the prediction as h1. Okay, here in the second decision tree I am passing the error as a target. This is my actual is my y, h1 is my prediction. Actual minus prediction is error, I am passing it as target. Okay, this is my independent feature as it is. Okay, this error I am passing to the second decision tree. Again I am getting the prediction as h2. Okay, here in the third decision tree, what is my actual? Y minus h1 is my actual, minus prediction is h2. Okay, the second decision tree error I am passing to the third decision tree as my target. The independent feature as it is, then I will get the prediction H3. Okay, this is the way we are mainly training our XGBoost model. Okay, we'll take one example how we are training and also how we are predicting with your new test data. Okay, here I have the two independent feature x1 and x2. This is my target data, independent dependent feature and two independent features. Okay, first step, consider the initial prediction 0.5. Why? Because in case of our logistic regression, the 0.5 is our threshold. That's why I'm taking 0.5 is my prediction in the initial case. I don't know the initial threshold. That's why I'm taking 0.5. Okay, 0.5 is my prediction for the all the records. Okay, then I am calculating the residuals. Okay, here actual minus prediction, 0 minus 0.5 minus 0.5, 0 minus 0.5 minus 0.5, 1 minus 0.5 plus 0.5. These are all are plus 0.5, 0 minus 0.5 minus 0.5. Okay, I got the residuals. This residuals I can pass to the next decision tree. Okay, here I'm just passing this same data to the first decision tree. Okay, next the step 1 we already taken the threshold, and from the threshold we calculated the residual. The second step, we need to split our decision tree as per our independent features, based on our independent features. Okay, for example, I don't know the threshold of my this binary tree. That's why I'm just taking the less than 20 is my threshold. Okay, less than 20 I'm just separating my decision tree. Here my record less than 20 I'm considering it as a left division. In case of right side, I'm taking the remaining all other records. For example, less than 20 I'm taking for the binary split. Less than 20, these three records comes under the left side, and remaining 20 to 30 and greater than 30 will comes under right side. Okay, here I have the all the residuals here. Okay, now next step we need to calculate the similarity weight. Okay, the nine records I am passing to the x1, so I need to calculate the similarity weight for the x1. So we need to use this formula to calculate the similarity weight. Sum of residuals whole square divided by sum of previous probability multiply 1 minus previous probability plus lambda. Okay, here I have the nine residuals. That nine residuals I am just adding it here, minus 0.5 minus 0.5 plus 0.5. From here all are plus 0.5 until last one. Okay, here nine records, I all the residuals I have added here, and whole square I got the numerator here, divided by, for every residual we need to take the previous probability multiply previous probability. This is the first residual, previous probability multiply 1 minus previous probability, plus for the second residual, third residual, fourth, fifth, sixth, seventh, eighth, ninth. For ninth residual, we need to repeat this previous probability multiply 1 minus previous probability. For every residual, we need to add this previous probability multiply 1 minus previous probability. Okay, I have added for the nine residuals. I have added my previous probability multiply 1 minus previous probability. Then last one is my lambda is my constant, one of the hyperparameter in our XGBoost. Okay, by using this formula I have calculated. Here I just passed the nine records. For the nine records I calculated the similarity weight. I got 0.69. Okay, similar way I have the left side, we have only three records. See here I have taken the binary split less than 20. That's it, this three will comes under the left side, minus 0.3 minus 0.5. Sorry, this one is minus 0.5 minus 0.5 zero point 0.5. Okay, these three records we need to calculate the similarity weight. Here I need to just add the all the residuals, minus 0.5 minus 0.5 plus 0.5 whole square. This is my numerator, and denominator for the first residual 0.5 multiply 1 minus 0.5 for the second residual, for the third residual plus lambda. Okay, similarly I have calculated for the similarity weight for the left side leave. Similar way I need to calculate the right side leave. I have the six records here, six residuals. For these six residual we need to calculate the similarity weight. Here I just added all the six residuals, 0.5 0.5 0.5 0.5 0.5 minus 0.5. Okay, all six residuals I have added here, whole square. Then here for the first record, second record, third record, fourth record, fifth record, sixth record. For all the six residuals, I have added my previous probability multiply 1 minus previous probability. I have added my lambda. Okay, here I have calculated my similarity weight for the root node as well as my leave node. Okay, initially I don't know, this is my x1 feature. x2 we'll discuss later. Okay, first I want to confirm whether my x1 whether it is better split or not. Okay, initially I don't know the better split. I just taken the less than 20 I have considered is my first binary classification. But in this case we need to calculate the gain. Which one is better split? We need to calculate the gain which is having the highest gain, that is my better split. Okay, similar way we need to calculate the gain here. Just we need to add the sum of weights of the leaves. I need to add the both the leaves weight minus weight of the root node. Okay, here I have used the same formula. I am just adding the leaves weight minus root weight. Okay, just I got the 1.05 is my gain for this split. Okay, similar way I'm just splitting using the another technique. Okay, I have the these two less than 20 and 20 to 30 I am taking for the left side, and the last three records greater than 30 I am taking for the right side. Okay, here similar way I am just dividing into the binary split. Okay, these six records I am taking for the left. Here see the my threshold less than 20 and 20 to 30 I am taking for the left side, and remaining last three I am taking to the right. Here greater than 30 I am taking to the right. Okay, I need to check whether which one is better better performance. I need to calculate the gain for the this split as well. Okay, similar way I just calculated for the root node as it is. We have the 9 residuals. For the 9 residuals, I have calculated the similarity weight. I got the similar way. Okay. Then for the these 6 records, for the left side I have less than 20 and 20 to 30. Okay, this is all are 20. Okay, this is a 20. Sorry, this is a 20. Okay, next 20 to 30 I am taking the these 6 records minus zero point 0.5 minus 0.5 zero point 0.5 zero point 0.5 zero point 0.5 zero point 0.5. Okay, these 6 records I am taking for the left side. Then I am calculating the similarity weight for this 6. Okay, if I see here minus zero point 0.5 minus zero point 0.5 plus zero point 0.5 plus zero point 0.5 plus zero point 0.5 plus zero point 0.5. I have added all the residuals whole square. Numerator I got. Denominator for the first residual for the previous probability multiply 1 minus previous probability. Similar way I am calculating second residual, third, fourth, fifth, sixth residuals, and I am just adding my lambda. Okay, I have calculated similarity weight for the this left side. Similar way I am just adding the similarity weight for the right side as well. Okay, here I have only the 3 records. I need to sum the 3 records. Zero point 0.5, zero point 0.5 minus 0.5. 3 records, 3 residuals, whole square divided by for the first record, second record, third record plus lambda. Okay, similarity weight I just calculated. From the similarity weight we can calculate gain easily. Okay, we need to add the two leaves similarity weight minus root weight. Okay, similar way I just adding the these two component q6 t6 minus this s3. Okay, I just done the gain calculation. I got the minus zero point 0.5. Okay, this is my better gain. That's why this is my I will consider this is my better split. Okay, if I take the less than 20, if my binary split my threshold is less than 0.5 is my better split. Why? Because my gain is more. That's why I'm going for this decision tree. Then from here I have the high and low. Okay, from here my x2 if it is high I have two residuals 0 0.5 0 0.5. I am just going to the left side, and if it is L my x2 feature is L, I have only the 0 0.5. Okay, similar way I just divided my residuals. Similar way we need to calculate the similarity weight. Okay, minus 0 0.5 minus 0 0.5 two residuals whole square for the first residual, for the second residual this is a previous probability multiply minus 1 minus previous probability. This is my lambda. Okay, similar way I have calculated. Similar way for the second leave also I have calculated. Okay, this is a left side, this is a right side. Okay, plus zero point 0.5. Okay, similar way I calculated the weight. Okay, this weight we are using for the prediction or as well as the for the next probability calculation. That's why I just calculated the weight. Okay, next we'll calculate the base model output. Okay, base model output we need to calculate by using the probability. I have the already probability. By using the base model output by using log odds. Why? Because we are using the logistic regression. Log of p divided by 1 minus p. Log of 0.5 divided by 1 minus 0.5. 1 minus 0.5 means 0.5. 0.5 divided by 0.5 is 1. Log of 1 is 0. My base model output is 0. Then we can calculate the probability for the first record. Okay, here I have the residual. From the residual uh, we have build our we have created our decision tree. From here we can calculate our probability of the first record. Okay, if I want to calculate the probability of first record, we need to know one of the formula: x equal to base model output plus learning rate multiply weight. This is a learning rate is a constant 0 to 1, we can take any of the value. Then weight from the leave we need to take. The base model output is 0. Okay, already we calculated the base model output is 0. 0 plus learning rate I just taken it as 0.2 multiply 0.6. For example, for the first record, right, less than 20, I will come to here. My x2 is high. Okay, here x2 is high. I will go to this leave. So that I am taking this weight as my reference 0.6. Then I calculated. I got the x value is 0.12. Okay, I got the x value. From the x value we can calculate the sigmoid function. For probability we can calculate 1 divided by 1 plus e power minus 12, so that we can calculate 0.52 I got. Okay, this probability I have replaced it here. Okay, for the next record, okay, for the second record also it is also high, it will comes to here. I will get the same probability. For the third record, if you see less than 20, I will come to here. If my x2 is low, I will come to the right side. My weight is 0.2. Okay, here for my base model output is 0. 0.2 is my learning rate is constant, multiply here weight of my this leaf is 0.2. Okay, similarly I calculate, I got the x value is 0.04. Okay, here I am just replaced 1 divided by 1 plus e power minus 0.04, then I got 0.51. Okay, similarly I got the probability. Okay, this is the way we need to calculate the probability for the next model. Okay, here we need to calculate our probability for a similar way for all the records. Okay, similar way, for example, for the right side also we need to divide. Okay, here high, low, medium, we need to divide our residuals. Then we need to calculate the similarity weight. From that we need to calculate the all the probabilities. Okay, once we have the all the probabilities, then we can calculate the residuals. Okay, here actually 0 minus 0.5, I got the minus 0.2 minus 0.52. Okay, similar way, what is my actual 0 minus 0.52 minus 0.52? Here 1 minus 0.51, I got the 0.49. Okay, here this is my residual. This residual I need to pass to the next decision tree. Okay, similar way we will try to build a next decision tree by using these residuals. Okay, by using first residuals, base residuals, we have created one of the decision tree. For the second residuals, we need to create the another decision tree. Okay, similar way we need to build our we need to calculate our similarity weight. We need to calculate the gain, which is the best split. We need to create that model, and after that we need to calculate the probability, and from the probability we'll calculate the residuals. Okay, this process until whenever we got the actual is actual and prediction also same, until that much time we need to repeat our sequential decision trees. Okay, here I got the residual for the model 1. From this model 1 I will try to pass this residuals to the next model. Okay, if I want to calculate the prediction for the new data, okay, let us take here I have taken the for new test data x1 less than 20. Here I got the less than 20, I will go to this root, and x2 is high. Okay, here x2 is high, I will go to here. Okay, then I can calculate the x value is very easy. Now my base model output is 0 plus my learning rate is always constant 0.2. Here my weight of my first decision tree, my weight is leave weight is 0.6. 0.6 equal to 0.12 I got. From this x value we can calculate our probability easy. My prediction probability equal to 1 divided by 1 plus e power minus x means 0.12, then I got 0.252. Okay, similar way we need to pass similar way we need to go to the next decision tree as well for the different residuals, right? This residual we need to create our next decision tree. We need to pass our similar way. If x2 is less than 20, and we'll go to the that next decision tree leave also. For example, next decision tree leave output I got zero point 0.2. Okay, similar way we need to expand our all the models. For example, here you see base model output is 0 plus 0.2. Here 0.6 is my weight of the first decision tree. Okay, similarly if I am going to the next iteration, okay, this learning rate is constant, multiply for the second model, second decision tree, for example output leave is 0.2, let us assume. Okay, then we will get the other x value. Okay, similarly we need to expand our this equation like this. Okay, base model output summation of learning rate multiply weight of the first model plus learning rate weight of the second model output leave. Similar way we need to take this equation, then finally we'll get the x value. That x value we need to replace it here, we'll get the final prediction. Okay, for example I got the, let us assume I got the 0.52. For example, if I am going to the 10 decision trees, I got the 0.52. Okay, if my threshold is zero point 0.5 greater than zero point 0.5, if my prediction is my probability is greater than zero point 0.5, then my prediction is 1. If my probability is less than zero point 0.5, my prediction is 0. Okay, this is the way we are predicting. Okay, just if you want to just understand better, then you need to go through the video once again. Okay, here these are all the calculation we need to perform in case of our XGBoost. Okay, we will take one data set, then we'll try and also predict using the XGBoost. Okay, here I have one kyphosis, one of the target data. If it is categorical or binary, we can apply our classification model. We have x1, x2, x3. We have three independent features, and we are just passing the, here if you see age number start, these three are independent. This is my x, this is my y. Okay, next we need to divide into the four parts. Okay, train data, this is my 70% of the train data I am taking, remaining 30% of the data I am taking for the test. Okay, if it is my y column, I will represent as y train. If it is my x column, I will represent as x train. Okay, similar way, if it is my y column, y test. Similar way, if it is my x column, x test. Okay, once you have the all the parts, so that we can train. If I want to train our model, I need to pass the x train and y train to train our model. If I want to test our model, we need to pass the x test. Then we'll get the y prediction. Okay, then we can calculate the efficiency between what is my actual data, what is my prediction data. Okay, then we'll take okay, this is already I have done in my Jupyter lab. From that I export as HTML. Okay, then we'll discuss here XGBoost classification. Import the libraries. Okay, here I am just importing my pandas as PD. Is my pandas, I'm keeping my alias name as PD. Okay, importing data set. This is my data set, is my object equal to PD is my pandas dot alias name of pandas. Read CSV is a method. We can access our kyphosis CSV. This complete CSV I am accessing it here, so that the complete four columns data will be available in this data set. This object dataset dot head. If I am displaying using this command, it will display the first five records. Okay, whether I am taking the exact data set or not, we want to just confirm using this command. Okay, absent present 71, 158, 128. Okay, here I just taken the same data set. I'm just confirming using this command. And here data pre-processing. Okay, here I need to mention what is my x and what is my y. Kyphosis, I'm just mentioning it as my y, and remaining age number start I'm considering it as x. Okay, here my x is, I'm just dropping my kyphosis in my complete object, so that the remaining age number start will be in x. Okay, next here I am just taking the kyphosis to the y. Okay, if you just print the x, it contains age number start three columns, and y contains only one column, kyphosis column. Okay, here I just printed all the x and all the y. Okay, here splitting the data set into the training and test using the train test split method. Okay, from scalar model selection, import train test split method. Okay, this is the train test split method. I'm just passing my x and y. Okay, here already we discussed. First we need to mention what is my x, what is my y. Okay, after that we need to divide into the four parts as we discussed. If it is train data, I need to mention x train and x test. Similar way, x test and y test. Okay, here I am just passing the x and y. I am just mentioning my test size is 0.3. That means remaining 0.7 percentage of the data I am using for the train data. Okay, here the random state always we need to mention, otherwise we will get the different prediction for each and every time execution. Okay, here x train and x test, y train and y test. I got the four parts. Okay, so that we can, if I want to train, so that we can pass the x train and y train. Okay, here before that, for example, if this package is not available, this XGBoost classifier, so that we need to install using this command pip install XGBoost. Okay, it will be installed, and after installing only you are able to execute your code. Okay, from sklearn matrix import accuracy score. If I want to calculate the accuracy score, just I am importing my accuracy score method. From XGBoost, import XGBoost classifier. I am using the XGBoost classifier to execute our data set. Okay, here XG is my object, XGB classifier. I'm using my class. I'm just accessing my class using the object dot fit. Fit is my method. I'm just passing the Xtrain and Y-train to train our model. Okay, here I'm just passing my Xtrain and Y-train to train our model. Xtrain and Y-train to train our model. Okay, here my training is done. Here we need to discuss what is my lambda is always 1. Here learning rate is 0.3. Okay, these three I think mainly we need to discuss here. Okay, here xc is my object dot predict. I am passing my x test, then we'll get the y prediction. As we discussed here, if I want to get the y prediction, then we need to pass the x test to the model, then I will get the y prediction, so that we can calculate the efficiency between the what is my actual data, what is my prediction data. Okay, here I'm just calculating the confusion matrix. PD is my pandas. I'm using the library, and here I'm using the cross tab my method. I'm passing the y test and y prediction. This is my rows. I'm displaying my actual data. Columns I'm displaying with the prediction data. Import cbone as sn. For example, if I want to represent in a graphical format, then we need to use the cbone. Heat map, just I am passing my confusion matrix here. Just I am mentioning it as annotation true, so that it will display in a graphical format like this. Okay, actual is the rows and prediction is columns. Okay, here actual is absent, and also prediction also absent. Okay, this is the correct prediction. And actual is present, actually is present, and prediction also present. Okay, this is also correct prediction. Okay, these two are correct predictions. Actually is present, but prediction is absent. This is a wrong prediction. Actually is absent and prediction is present. Okay, this is also wrong prediction. Okay, these two are wrong prediction, these two are correct predictions. Okay, 20 divided by out of 25, then I got the 0.8. That means 80% of the efficiency we got using this XGBoost regression. Okay, XGBoost classifier. Okay, here I'm just calculating the accuracy score using this method. Accuracy score, I'm just passing the y test and y prediction. Then we'll get the accuracy of the model. Okay, thank you friends. Thank you for watching.